Welcome, everyone. Thank you so much for joining us today. My name is Lauren Manier, and I am a Senior Program Associate with the Inclusive STEM Ecosystems for Equity and Diversity, or ISEED program at the American Association for the Advancement of Science, and I work on the AAAS Arise initiative. We are pleased to be hosting today's webinar titled Engaging Pre-Service Teachers in STEM Research, and we are excited to hear from our presenters today, Dr. Christine Kudaszewski and Dr. Elisa Stone and Ari Jamshidi. Before we get started, just a couple of housekeeping notes. This presentation is being recorded, and a recording and the slides will be made available in the coming days on our website at AAAS-arise.org. You will also receive an email with a link to these materials. Please note we will transition into discussion and Q&A breakout rooms following the presentation, and these breakout rooms will allow for deeper engagement and they will not be recorded. We also have closed captioning for this webinar. If you can download and view the full transcript by clicking the CC button at the bottom of your screen. Now, before we jump into the webinar, here's a little background about AAAS and Arise. The American Association for the Advancement of Science was founded in 1848 and is the world's largest multidisciplinary science society and a leading publisher of cutting-edge research through the Science family of journals. AAAS is dedicated to advancing science, engineering, and innovation to benefit all people with the specific goals of strengthening and diversifying the science and technology workforce and fostering education in science and technology for everyone. And more information is available at AAAS.org. Arise, which stands for Advancing Research and Innovation in STEM Education of Pre-Service Teachers in High-Needs School Districts, seeks to provide resources, tools, and a community to foster research and evidence-based innovation in STEM teacher education and leadership development programs. The Arise Network, which builds on AAAS's provision of technical assistance to the Robert Noyce Teacher Scholarship Program, collects and shares information about topics and strategies for research and evidence-based approaches to prepare STEM teachers for the workforce, assess efficacy of teaching, and to understand effective ways to recruit, train, and retain a high-quality STEM teacher workforce. You can learn more about Arise on our website or LinkedIn page. You can also follow us on Twitter to stay up to date on our latest blogs, newsletters, and events, or share what you've learned about at today's workshop. So now, without further ado, I would like to turn it over to our first presenter. Christine, over to you.
As Lauren said, I'm Christine Kudaszewski. It's so nice to see some familiar faces in the crowd too. Thanks so much for joining us on this afternoon. I'm at the University of Nebraska at Omaha, so I'm in the middle of the country. And today it's kind of a typical fall, cool day. The rain started a little bit through the day, and so this is the fall themed background today too. I hope that you're enjoying some beautiful fall colors with the trees near you and some nice weather. So today we're talking about a story in Nebraska specifically. I wanted to share with you a bit about our Noyce program and some of the research data that we've collected on our program. Our NoyceSCIENCE program was begun in 2017, and so we've been able to study it for several years now. And of course, thanks so very much to the National Science Foundation for supporting this work. Today, I'll be sharing about the lived experiences in teaching and research. We really think about our Noyce scholars in terms of preparing them to be scientists and then preparing them to be teachers. So I think you'll find that as the theme throughout today. If you're not too familiar with Nebraska, I hope the folks who have at least been to Nebraska or maybe have lived in Nebraska will post in the chat about their favorite memory of Nebraska or time here. But our needs are very reflective of that of the entire United States. We certainly have a huge need for more teachers in the state of Nebraska. We also have what we hear all the time, a need for H3 jobs. So those high skill, high demand, high wage types of professions, of which teaching is included in that. We also have a lot of workforce deficits in STEM in general. So I'm a biologist by training, and I've converted to kind of be the science education researcher as well. And I lead our our STEM Teaching, Research, and Inquiry-Based Learning Center, or STEM Trail Center, on our campus. And workforce is something that we're really passionate about with that. We're trying to make sure that students have the training that's necessary in order for them to be successful in terms of their careers, and to provide a little bit more talent for the state. Just to give you a small snapshot, today in Nebraska, 20% of STEM jobs are unfilled. So we really have this stark need here in the state. One of the ways that we are working to combat that is through expanding teacher preparation pathways. So that's what I'll be sharing with you today. I pulled the statistics on teaching needs today. So this is November 10th, 2021, and these are the current teaching jobs open in Nebraska. So it's not an Omaha problem, it's a across Nebraska problem. And again, I think if you look at the snapshot of the US, we really have this tremendous need for more teachers of STEM disciplines. Similarly, if we pan over to just the science and technology side of it, and thinking about workforce, thinking about those quote unquote H3 jobs, we've seen a huge decline in the number of US patents awarded to companies in the US. So that's captured in this blue line here. The number of US patents awarded has declined significantly. Of note, the federal government has decreased spending to science and technology research and development in the year 2000. So as a result, we've seen this continued decline. Whereas the majority of US patents are currently held by companies that are located outside of the United States, more than half. So we certainly have this stark workforce need and the need for more folks in R&D surrounding STEM and technology in general. We're trying to combat that by providing some pipeline programs. Speaking yesterday about this very thing, and a lot of folks share how we need to build a pipeline, we need to facilitate new programs. We're really in the business of trying to fix the leaky pipeline as opposed to making new things. I think there's a lot of great evidence in the literature surrounding what is a high impact practice to supporting students, and I'll share with you some of our data today as well. But what we're trying to do is mentor students at all levels of their education. So for instance, we have programs like the Noyce program, our pre-service teacher support program, as well as our Nebraska STEM for You program, or AnySTEM for short. The AnySTEM program is one where our Noyce scholars, undergraduates, go into the out of school time and provide STEM content for kids. This is an opportunity for them to serve as the role model for kids. It's also the opportunity for kids to get their hands dirty with science. I was one of those kids that thought reading about science was quite boring. Actually, I think I'm still in that camp. Reading about it can be pretty boring, but doing science and participating in the process is so exciting and so engaging and so rewarding. I can still remember vividly how I felt after I published my first paper. It was very exciting, and it still is. Science is just so cool, and we want to share that with young children. And so really that program is designed to be a pre-professional training program for our undergraduates. And that's where we can support undergraduates really comprehensively at building the skills necessary for them to walk right into the workforce and be successful. So we have these programs that serve youth, and then we have, of course, the experiential learning opportunities through these pre-professional training programs. We have a seminar series devoted to supporting undergraduate and graduate students, and we have directed mentorship by faculty. And the students have access to faculty mentors in our College of Education, as well as our College of Arts and Sciences. So again, bridging that gap. Ultimately, what we hope is then the students that go through our pathways then end up in the job of their choosing, whatever that may be. But whatever is most interesting to them And then, of course, we hope that after they're into the workforce, they'll come back and serve as role models, speakers, mentors for others. So that's how we're trying to address some of the workforce needs surrounding H3 in general. So I hope I now have shared that there's certainly a need for more science and technology preparation in our state, and really that being reflective of the country more widely. And we have some programs in place in an effort to contribute. And today we're talking a little bit more about our Noyce program. So prior to getting our NoyceSCIENCE award from the NSF, we did not have any dual pathways for students. We exclusively had a pathway where students could go into a teacher preparation pathway. So we had a lot of students who were past engineers and were coming back to school and wanted to become a teacher, or past biomedical researchers who then wanted to come back to school and become teachers. And we didn't quite have a spot for them. We also have on our campus a very large pre-medical population of students. Perhaps your campuses are similar. This seems to be the trend. A lot of folks are interested in medicine. And then there's kind of this switch over that happens, sophomore year, junior year, where students start thinking, do I really want to go into medicine? Or is it that I want to help people and I love science? And we know that if you want to help people and if you love science, teaching science is awesome, because you can see gains in your students each and every day. You have the opportunity to feel their enthusiasm and love for the subject, and you get to share your enthusiasm with them. So we encourage those students to consider the Noyce track or a dual pathway track to see if teaching might be for them. So one of the first things we did was we had to generate these pathways, right? So they didn't exist, we had to create them. And on our campus, that includes a range of sciences. I mentioned I'm a biologist, but we have a number of other types of sciences represented. So also chemistry, geology, and geography, and physics. And we wanted to support students no matter what area they were interested in. So we established these dual pathways and then made sure that they were in line with what the state requirements were. We recruited students to those pathways. As I mentioned, many of those students came from pre-med or pre-med focus. And then we had lots of students that would get to junior, senior year and weren't necessarily considering medicine, but just didn't quite know what they wanted to do, but they've always loved science. And so thanks to the internship opportunities provided through the NoyceSCIENCE program, they could get their feet wet, try out teaching, and see if it's something they wanted to pursue. The themes that we embed for all of the students through our program include research, teaching, and community engagement. And once I share with you some of our data, I hope that those will speak loud and clear through the data, because all of the students, all of our undergraduates have to do a research project. They also have to teach in one capacity or another. So the research might be that they're doing wet bench research in an apprenticeship style approach, or it might be students doing discipline-based education research. So the research part is very broad, and it's really catered to what the student's interested in, but they have to do that research project. They also have to participate in teaching, and that teaching could be serving as a near-peer learning assistant within a first-year science course. That's what almost all of our Noyce scholars do in terms of their teaching requirements. But they can also serve as teachers in our after-school time program, any STEM-free program I mentioned. And so it's a different cohort of students, obviously. It could be elementary age students, middle school students, or undergraduates, or all of them. And so that gives our Noyce scholars the real-time, on-the-ground training for teaching. And it's a really good indicator on whether they do like teaching or not. The community engagement is a bit unique in that our campus is actually a recognized Carnegie status community engagement campus. So community engagement is embedded into each and everything that we do. And through that out of school time teaching program, that is our community engagement arm, the largest one of our community engagement arms. We also have some service learning collaborations, and we do family nights also. But far and away, the Any STEM for You program is our community engagement component, so our students can participate in that. So I mentioned that the students have opportunities related to professional development, and that professional development takes a variety of approaches. The end goal, the ultimate goal for our students is to make sure that they walk into the job that they want. And we would sure love them to be science teachers because the need is great. So as a consequence, they do get mentoring both from science and education faculty. Students get assigned a primary mentor, but we have group meetings, and so they can access a variety of faculty members for their expertise. They also get connected to folks within our community. So for example, we host panels where they can ask questions to current science teachers and the science supervisor for our largest school district. They also get connected with our Omaha STEM ecosystem and our local district partners like our Metropolitan Omaha Educational Consortium. And then the more traditional ways that students can get connected with others through disseminating their research, going to conferences, giving presentations, and then of course, when it's not a pandemic, going to the AAAS meeting or going to NSF summits. They get that teaching experience, again, customized to the type that they're interested in. So for example, the majority of our students that want to end up teaching high school, they really flock to that undergraduate near-peer learning assistant role. For the students that are considering middle school, as a teacher of middle school, they flock more to the Any STEM for You program. Makes sense, but they have the opportunity to do both or choose one or the other. And what we've seen with that teaching experience, and I won't share those data today, but we have seen that our students have become more dependable. They recognize that they have improved communication skills and that they're more interested in serving their community as a result of that program. And then the last thing, excuse me, that we have focused on in terms of this program is adding course-based undergraduate research experiences. So if you haven't heard of CURES, think of it as if we're providing a research experience for each and every student. On our campus, we have more students than we do faculty members, and so not all of them can do apprenticeship style research. This is a way where we can really engage all of our students in research experiences to see if they like it or not. And our Noyce scholars support these programs by serving as those learning assistants. So we've been studying this program for several years now, and we've had a whole cohort go through it at this point. And we've conducted mixed methods for everything that we've done on the Noyce program specifically. And the framework that we've used for basically seeing how students are making choices on whether they want to go into teaching, and then as they're gaining competency in their teaching and research, we framed everything within Chickering's vectors. So thinking about student development theory and what are the steps necessary and what are the influential activities that support a student going through these different vectors. So these data are based on qualitative interviews with students and focus groups. And the emergent themes, we had 4 that surfaced from these. And the things that were most important to students were learning from experts, mentoring, the mentorship from their faculty, and then giving back, serving their community. So those things were a little bit surprising in that I personally didn't expect the volunteering experiences or serving their community to raise to the very top level. I really thought that would be kind of a bystander effect, an extra positive effect. But for students that have gone through the program, and perhaps it's because we are a community engaged campus, this stood out to them as being really important. There's been a lot of discussion in the literature on the influence of having faculty members as mentors versus graduate assistants, postdocs, so on and so forth. So I do want to point out that the students indicate that they really appreciated the opportunity to work with faculty mentors directly. Keep in mind that a lot of our faculty mentors were past science teachers, so it really gives them a wonderful opportunity to ask questions about the role and preparation for the role, and they have resources longer term then as they go into their practicum and then ultimately be practicing teachers. We have a range of those professional development experiences that students can participate in. And so of those, these were the ones that students thought were most important, most valuable. And I want to point out undergraduate research experiences. So that was consistent throughout. Students really valued the opportunity to participate as scientists and then learn more about teaching. They thought that there's a much bigger value added that they could provide to their students by mentoring them through things like Science Olympiad projects or things like that as a result of having those experiences. And then ultimately, as we would expect, students moved toward independence, meaning as they got closer to graduation, they felt more confident in their ability to do science, and their confidence in terms of both research and the teaching improved as well. We have some self-efficacy studies as well that have been ongoing, but I'm not sharing those data with you all today. But we see the same thing. Students see themselves as scientists instead of students, or scientists instead of teachers as they get ready to graduate too. So I pointed out a few of those key themes, but of research, I just want to hit on that again, and it's a bit heavy-handed, right? This workshop is focusing on research for pre-service teachers, but sometimes what we want our students to take away from an experience is not always what they do take away from an experience, right? I'm sure you've all done a focus group where you have what you expect the outcome to be, and then the students say something totally different, or where you think, oh, they're never going to say, well, I improved in my critical thinking as a result of right? We just never know what we're going to find. But again, that research seemed to be so important for preparing our future teachers. And this has been our intentional approach to prepare students as scientists first, and then teachers. So they get to participate in those research experiences that range from culturing bacteriophages to studying the student learning outcomes of middle schoolers in our out of school time program. So we have a range of these activities so that they can go as deep or as superficial into research as they would like, but they still get the full process of research. They have to go through the process of sharing their knowledge with others, whether that's simply at the conference or a presentation format or through publication. Critical thinking gets thrown around a lot these days, and this is usually what folks don't necessarily buy the most. So I want to share with you a little bit about our data in terms of critical thinking. I was one of those critical thinking skeptics. I thought, you can't really measure critical thinking change for students. Will we see a change in such a short period of time? Will we be able to control for different variables to see that change? So I wanted to share with you a bit about our data that we've found in terms of change in critical thinking abilities within our students that go through the AnyStem for You intervention. The intervention, of course, is really meant as a pre-professional training program. Again, we want our students to walk into the field and be exceptional scientists and exceptional teachers. So can we measure that, right? So we use the California Critical Thinking and Skills Assessment, and that's what's pictured on the right here. And we compared students that went through the intervention versus those that did not, and then pre-post. The error bars are huge. I would expect that. Every student's a little bit different. But we did see two statistical significance in that students in our intervention scored a little bit higher on analysis and inference. These are just some of the subscales within critical thinking as an overall assessment using the CCTST. So for what it's worth, that's what we're measuring. We also dug deeper into quantifying a bit more around the Chickering's dimensions. I shared with you in that big circle that we looked at the qualitative data on how students reported the intervention. And here is just a different way to really see what stood out to students the most. Here we're looking again at those different dimensions, walking through the vectors established by Chickering's in the 1960s. And again, what stood out the most, so you can see students really value being a learning assistant. So serving as the supporting near peer within the course-based undergraduate research experiences. They also highly prioritize being a mentor for others. I should share more about what this being a mentor really means. Students that are veteran members of our groups, meaning those that have been in for at least a year or more, serve as mentors for the new incoming students. Those students also serve then as role models for the children that go through our program. So the undergraduates are seeing a value in providing that mentorship for near peers and then also the children in our program. And then the last one that really stood out was undergraduate research experiences. We all love science. That's why we're on this call. And it's really exciting to be able to cultivate that into our students as well. We did capture progression through the dimensions. In our program, we have both intern level and scholar level. And so as students enter the university, they can participate in an internship, which might be one semester or for a summer. And then once they've committed to being a science teacher, they can be supported as a scholar. So that's in their junior and senior year of the program. So does it matter if they're an intern or a scholar? Do we see any change in their science identity? Do we see any change in their progression through student development as a result of how much time they have in the program or at what level they're committing within the program? And then also, do we see any change over literal year time? So that's what we're trying to show here. So on the bottom, we have the progression for our interns, and it's tracking them across summers. So for example, you can see that developing competence was the largest contributor for summer number 1, but then in summer number 2, the students moved more toward independence. This is the ideal situation. They're seeing themselves more as scientists. They are feeling more confident and independent. Scholars, interestingly, expressed this a little bit earlier. Certainly they see the need to develop competence and learn from others, but establishing an identity is very small, and moving through autonomy towards independence was also highly represented. In a subsequent survey, subsequent year, again, that developing competence is continuous. That's great. That's what we would expect to see. And then interestingly, fewer students report moving through autonomy towards independence. What we expect is happening here is that students come in a bit maybe overconfident when they're reporting here. And then once they get into more of the research experiences, they're realizing additional opportunities for growth. But we have to pick that apart more and learn more. So we certainly engage mentors with those research projects, and we want to make sure that they have the opportunity to connect with the community as part of our community engagement initiative. They have that near peer network, working with the other students in their cohort program, and then they get to serve the undergraduates in the course-based undergraduate research experiences as well. So in closing, I wanted to just put a plug in for a new project we have going on related to lesson development. And we're having our pre-service teachers work on this project as well. We've been trying to develop out comics as another way to engage with kids and develop resources for teachers. So with that, I'd like to acknowledge my great colleagues that have done a lot of this work. Dr. Summers, Dr. Gomez-Johnson, Dr. Tabrish, Dr. Grangenet, Dr. Rivera, Dr. Jacopovic, and Dr. Conrad. And of course, none of this work would be possible without the wonderful students we have participating in our program, in the NoyceSCIENCE program, and our many community-based collaborators. And then of course, a major thanks to the NSF and my institution, UNO, for supporting our work and giving us these opportunities. And we won't have questions now. We're having a question and answer session after Dr. Stone and Ari's talk. So I'm looking forward to hearing from you then. Thanks so much for your attention.
Great, thank you so much, Christine. I would now like to turn it over to our next presenters, Dr. Elisa Stone and Ari Jamshidi.
Hi, everybody. Look forward to talking with you about some of the things that we're doing here at Berkeley. around engaging pre-service teachers in STEM research. We're going to divide this presentation for around 5 themes. First, talking a little bit more, extending some of the thoughts that Christine shared with us around why should we engage pre-service teachers in STEM research, about our current Noyce project, which we call Berkeley 3D, and also how it synergizes with an RET and IU's NSF award. Ari's going to tell you a little bit more in depth about what research experiences are looking like in the last couple of summers, evidence for undergraduate learning during the research experience, and then a little bit of data on translating the research experiences to the classroom. Next. So, of course, some of these things that Christine shared are similar to the goals for many of us that are involved undergraduates in general in research. It improves understanding of content. They develop the knowledge and skills and scientific practices like formulating a research question or analyzing data. They build an understanding of the nature of science, improve their own self-confidence and identity as a STEM researcher, and it increases STEM retention and interest in STEM careers. Next. So future teachers have an additional benefit when they engage in research. They learn how to promote inquiry for their future K-12 students, especially with a deeper understanding of scientific and math practices, as well as the nature of science. And they develop a research stance for their own teaching practice. Who are we in CalTeach? So there's actually 8 different CalTeach programs across the state. At Berkeley, we're an undergraduate STEM teacher education program. CalTeach students simultaneously earn a STEM degree and a secondary math or science teaching credential before they graduate. And we have a series of courses that require CalTeach students to engage in research experiences and or K-12 field work. We require both of these things, a lot of it before they graduate. And one, some courses more emphasize the research experiences and some the K-12 field work and some both. So just to give you an idea of scale for our program at Berkeley, there are about 500 undergraduate students enrolled in our courses. About 400 of our students are placed in the field in local K-12 classrooms with more of a focus on secondary science and math classrooms. 50 to 75 per year that are graduating from Berkeley complete the CalTeach minor. Around 30 or more students a year engage in summer research or summer internships in informal science organizations like museums. Around 25 and growing receive a credential, and we award scholarships to around 10 to 14 folks a year. Next. So I'm going to tell you a little bit about our current project. We've had 2 Noyce awards in the past. And like those awards, and like many of you all across the nation that have Noyce awards, CalTeach similarly recruits a diverse undergraduate population, contributing to increased diversity for California teachers. It's one of our goals. With the new award, which we're now in our 2nd year of a 5-year award, we're calling it Digging Deeper with Data, or Noyce Berkeley 3D. Other broader impacts include anti-racist STEM pedagogy, which we're focusing on integrating across our course curriculum, especially including the use of data science approaches to explore and analyze data sets with a social justice lens. And in so doing, we're hoping to have a long-term goal of preparing urban and rural K-12 students in Northern California for college majors and careers involving STEM data literacy. Next. So our specific aims are to recruit around 65 Noyce scholars across 3 partner programs. CalTeach on the Berkeley campus, CalTeach on the UC Merced campus, which does not have a school of education, and also the graduate program here on our campus, which is called BE3, Berkeley Educators for Excellence and Equity. We also are supporting 90 or more internships for lower division students, get them excited about teaching, working with kids and families in museums, classroom, as well as directly in research. The focus of the 3D is, as I had mentioned, STEM data literacy integration, which we're really trying to support and infuse in more purposeful and explicit ways in our course curriculum and also in our STEM research groups, data literacy and data science practices. We are starting to offer workshops that are facilitated by former Noyce scholars, alums, who are currently teaching with 4 more years of experience for our new Noyce scholars, and that also focus on STEM data literacy. And we're working on getting professional development for CalTeach faculty in data science to kind of bring us all up to speed about the most current practices. And finally, we're beginning to engage in research and program evaluation around how does data literacy show up in the teaching practices of our graduates. Next. So I wanted to discuss, because you'll see this, as Ari presents and as we finish up, we've got several other NSF awards, including an RET award, which we call Beret Plus D. And an IU's award with chemistry colleagues that is focused on what the undergraduate researchers learned that extends our research. And so you'll hear a little bit about both of about the data and programmatic initiatives and those as well that are integrated with our Noyce project. Next, Ari.
Thanks, Elisa. So I think you have a better sense of who we are, kind of why we recruit and support STEM pre-service teachers, undergrads, and how a number of our projects work together, multiple funding sources, projects combined. I'm gonna dive a little bit deeper into the types of research experiences that a CalTeach student might expect and how we support their learning and growth during that experience. Next slide, please. So just to give you a sense of the range of research projects, this isn't by no means exhaustive, but I've listed just some of the divisions and departments in which CalTeach students have recently supported research. Included in here are also some projects where CalTeach students are not only conducting research themselves, but they're also working directly with K-12 students as part of that research project. And we're particularly interested in those projects because they really provide our CalTeach students with additional practice, whether it's with teaching, mentoring, and collaborating with young learners. So just to clarify, as part of the overall CalTeach program, students will complete a field placement in a classroom where they might student teach. So this is in addition to that. So the reason I really want to focus on some of these projects, the ones where the students work with K-12 students, is that we feel really strongly that when these students can kind of learn alongside the K-12 student, they have opportunities to kind of form a community of practice with those young learners. And it helps them develop a better sense of how people learn, in specific contexts and within certain constraints. Next slide, please. So to give you a better sense of what it looks like when a CalTeach student conducts research while working with K-12 students, I'm going to discuss just 3 recent projects. As Elisa was mentioning, with our focus right now on data science, we recently partnered with Berkeley's Division of Computing, Data Science, and Society. And the CalTeach researchers in this project really have to wear a lot of hats when they participate with this. They spend a certain percentage of time as learners, where they actually work with the high school students to learn new data analysis techniques and tools to complete a sequence of projects. As educators, they're going to also be mentoring those same students who are often participating really in their first college experience. And they also help the curriculum developers design certain aspects of the classroom experience, such as how to facilitate discussions. And finally, of course, as researchers, because that's primarily what they're there for, they use their emerging knowledge of data science to design and carry out different kinds of statistical analyses with an eye towards social justice. As part of another project that also works with high school students, we've partnered with the Joint Bioenergy Institute, and somewhat similar to the previous project, the CalTeach students, they're going to be learning microbiology concepts and research techniques alongside the high school students who are also in the program. The high school students and the undergraduate researcher are going to be guided by actual faculty research mentors to plan and carry out studies related to plant-based or alternative fuels. But additionally, the CalTeach student is going to be working with the research mentors to also design learning modules that are going to be used with those high school students and in local high schools. And then one more I want to focus on is an exciting one. It's a collaboration that we have with a group that designs web-based resources in science. And one of our students is supporting an effort to apply certain data science techniques to an enormous qualitative data set right now. And in this project, the CalTeach undergraduate is really helping to evaluate a web-based resource that's designed to help middle school students, in this case, to use data to examine the effects of environmental racism on the health of themselves and their family and community. And as part of this research, the CalTeach student is helping to identify a number of factors that are related to shifts in how those middle school students identify themselves as scientists, where they see themselves kind of on that spectrum, and as well as how they demonstrate their understanding of specific environmental science concepts. So next slide, please. One thing that you can probably imagine is that for this to be a meaningful experience for the CalTeach student and for them to feel some measure of success, it can be overwhelming. It takes a great deal of support. And though there are a number of scaffolds in place to help the students, including a research methods course offered during the fall and spring, kind of following the CURES model that Christine mentioned earlier, I'm going to focus on one experience in particular because it happens during the summer when students have far fewer academic commitments, and because I personally have an opportunity to support these students directly. And this is called the Summer Research Institute, or SRI, and it's an 8-week paid, fully immersive internship. And when I say fully immersive, I mean students are obviously working side by side with the researchers. They're attending all lab meetings, they're going to all lab events, they're going to special lectures that are put on that all the lab, the rest of the research faculty in that lab attend. They are doing everything with that lab. They're really kind of becoming immersed in the family of that lab. And accompanying, of course, the 8 weeks that they're going to be working in that lab, there is an upper division 3-unit course that's focused on 3 main goals, which is, of course, helping the students understand and develop their own research methods for maths, science, and data science specifically. Also, we are trying to help them develop their own identity as a researcher in these fields, in STEM fields. And ultimately, we want to help them translate a lot of those research skills that they develop into lessons that are designed to engage students kind of in meaningful math and science experiences. Now, along with the course, there's some additional guidance. We do provide them with scientific writing workshops, which means that there are certain opportunities that are open for them after their experience for publication, whether it's in a peer-reviewed journal with their faculty mentor, or in an undergraduate journal. We do invite them and have them come to research showcase events like poster sessions and career panels where they get to learn a little bit more about what data scientists and researchers do. And importantly for us, and I think we have to mention this, they get a significant amount of mentoring from their collaboration with in-service teachers who are also part of this project. And so they are not only working in a lab with the faculty mentors, but there's in-service teachers working in the same lab, also doing their own research, and they get to listen and talk with the teachers to really understand what are some of the constraints of teaching math and science in the classroom. Next slide, please. Now, regarding the goals of the Summer Research Institute, I'd like to briefly share just some of our preliminary findings as we look for evidence for how do undergraduates learn as a result of their participation in the Summer Research Institute that we just talked about. Next slide. And we're going to focus our findings on the following two questions. What do undergrads learn from this research experience? And we're going to split this next one up into two. How do CalTeach students and CalTeach graduates translate what they've learned in research, in the research placements and coursework, to actually teaching in the classroom? Next slide. So keeping in mind that we're still in the process of analyzing a significant amount of data, that other patterns might emerge, in looking at what the CalTeach undergraduates learn about research, as well as how they really view themselves, their identity as a researcher after the summer experience, we see from an analysis of the pre and post surveys that really being able to practice themselves, planning and carrying out an investigation is essential. That data analysis, remember, this is focused on data science, that data analysis is an essential skill, particularly for those who wish to help historically marginalized communities. And that data science has become more accessible, much more so, especially in the last few years, with the wide array of free data resources, free analytical tools, and all the tutorials that are available to kind of go along with that. So they feel very empowered to use this themselves and to bring this to the classroom. I've also selected two quotes here from some of the final portfolios that students had put together. This is a reflection on their portfolio during that summer course that I feel are representative of what many of the students said regarding how they kind of now see themselves as a researcher, as a scientist, as someone who is also a learner, and how they kind of feel like they can bring this identity to the classroom to their students. So I'll leave those just for a moment so you can see them. And you'll have access to these slides, of course. So why don't we go ahead to the next slide? And then with respect to that second question, how do CalTeach students translate what they've learned by actually doing the research into their future math science classrooms? I would say so far in our pre and post survey analysis, the one overwhelming emergent theme that seems to be coming up is that there is this shift towards understanding and articulating the importance of engaging students in the math and science practices. And these would be as defined by the Common Core for math and by NGSS for science. In looking at the students' final lesson plan, so this is again from their summer course, they have to develop a series of lessons. After they revise them, their final lesson plan, they reflect on it. We see some of the same ideas about the math and science practices echoed in these quotes that are pulled from those final reflections. And in particular, I want to draw your attention to the second quote, which really talks more generally about the practices, but more specifically about what it means to kind of empower their students to be able to articulate how they use practices in the classroom, whether it's math or science. And this as a way to ultimately help them understand the process of what they're going through, what they're investigating in the classroom. So we have one more result I think Elisa is going to share with you, and that is for the CalTeach graduates.
So I wanted to just mention sort of something that for anyone who's been involved in one of these research experiences, that feels like one of the biggest challenges is moving from, like sort of the research experience itself, in which, like there's a lot of evidence from many programs that it increases STEM knowledge, they increase the STEM practices, awareness, attitudes, and identity, into what is essential for research experiences for teachers, which is the translation to practice. And Ari just spoke about the professional learning community in the form of an upper division course required of our students, and how that supports them to translate what they've learned into practice, but by doing such things as supporting them to develop lesson plans that are really closely linked to their own research and showing how that they would support their students in their future classrooms or in their current field placements. So next slide, please. So I've just circled this as sort of a central key component for kind of building a teacher researcher. As Christine alluded to, that a teacher and a researcher are pretty different, but that some teachers are also researchers. This is a sort of a term kind of that I pulled from Cal State colleagues, for the STAR program here in California. And, like the goal is to support students, to be persistent in the STEM fields, to create a positive STEM positive identity for the teachers to teach more authentic STEM classes, activities, enact lesson plans, and then, like with a long-term range of student impacts. This model actually comes from work that I was involved in with the CARET group, which is collaborative around research experiences for teachers, published 2 years ago, an article by Krem and others in CBE Life Science Education. I would encourage you to read it. It was a lit review that really pulled together a lot of different goals and areas that we still need to do a lot of research in around these research experiences for teachers and pre-service teachers. Next. So in translating research into the classroom, we really have extended the RET and Noyce program evaluation in a collaboration through an NSF-IU's award with the Department of Chemistry. We call this project GURET for Berkeley Undergraduate Research Evaluation Tools. My colleagues Ann Berenger, faculty in chemistry, Marcia Lynn, faculty in the Graduate School of Education, and graduate students Max Helix and Lale Cote have been involved. Next. We have had 3 research questions. One of them has been focused more on what do undergraduate researchers learn about scientific content and research practices and the integration of the two. There's an article that's coming out in ChemEd Research and Practices in the next months. We've also focused on graduate student workshops that support their mentoring of their undergraduate researchers. And that's ongoing research. And I'm going to just give you a little bit of insight into preliminary data in what ways do CalTeach undergraduates, pre-service teachers translate their research experience into, actually not CalTeach pre-service teachers, but CalTeach teachers. How do they translate their experience into K-12 classroom practices once they start teaching? So some of what we see are more general kind of themes, like Mr. C, who engaged in research on characterizing thermal and electrical conductivity in one of our engineering departments. In so doing, he had to develop models to explain the phenomena that he was researching. And so he tries to translate the models-based thinking into his own classroom in a variety of ways. Another version that we frequently see is from Ms. L, where she has her students create notebooks, science notebooks with their thoughts and ideas as they develop the material. I think kind of an interesting twist to, science notebooks, like in writing in a kind of composition book, is kind of the move toward electronic science notebooks, and what are the benefits and ways that one could use those to best advantage. Ms. L also talks about, helping her students think outside the box and try to solve problems and actually lead learning in the classroom. Case number 3, next, provides kind of a very specific example about Ms. A, who talks a lot about, her comfort with reading primary literature. And it's allowed her to quickly, identify and synthesize papers, in this case, one measuring water turbidity, to create a simple apparatus and work that she did in a summer experience with Tanzanian students. so that they could evaluate their local water supply and improve health in their community, which she later brought into her teaching in her high school class in Oakland. So we're just going to, in closing, would like to kind of focus on this attention to translation to practice that I think that it is really a goal for us, and I believe for others in this kind of work. Next. Please contact us if you've got questions. Next. And just want to acknowledge the National Science Foundation, Noyce RET and IU's projects, as well as collaborators and staff and faculty who support our work. Thank you.
Thank you so much, Elisa and Ari. We're now going to transition into some breakout rooms for Q&A. Okay, great. Welcome back, everyone. Thank you for sticking around for the Q&A and discussion session. I'm wondering if we can get our presenters to share a quick 1-minute recap of their Q&A session and provide any closing thoughts. So we'll start with Christine.
Thanks, Lauren. We had a wonderful discussion. A lot of folks share the enthusiasm for supporting students as they think about becoming scientists, researchers, and then teachers. And one of the things that I did not mention was our continuous support for teachers after they do graduate and go into in-service. So much like my colleagues in California, we have what we call Teacher Researcher Partnership Program. So if you're interested in learning more about that, I'd encourage you to take a look. But really, I think the best thing you can provide your students is surrounding them with a dynamic ecosystem of folks who love science and love teaching, so that they can get both the research experiences and they can also get the pedagogy. So I know that a lot of folks already have that enacted. It's wonderful. Would love to hear some of your great stories and read more about your programs. So please do share those, and please share any suggestions or feedback you have. Thanks so much for letting me visit with you all today.
Great. Thank you so much for being here, Christine, and for providing that recap. I'll turn it over to Elisa.
Thanks. I feel like that there was some generative conversations at our breakout. They included some other people sharing, how that they're thinking about and engaging pre-service teachers and teachers in research on their own campuses, how you might start small, if you don't have one but are really interested in, and having undergraduates engage in research, especially those thinking about teaching, and some conversations about, like in the cases where you pair a pre-service teacher and an in-service teacher on research, like what are some of the benefits? How do they, how you set up kind of mutual learning from each other? Ari, do you have anything to add?
Nope, I think that's good. Thank you.
Awesome. Well, thank you both. And just before we go, I wanted to thank all of our speakers today, Christine, Elisa, and Ari, and the rest of the AAAS Arise team, Travis York, Betty Kellinger, and Thomas Fague, as well as all of you who were able to join and participate in today's webinar. And we do have a post-event survey link, which has been being posted in the chat. And we would really appreciate your feedback on today's workshop. The survey will only take a few minutes. And if you'd like to get involved in the Arise Network by writing a blog, presenting, or sharing your research, please reach out to us at noyce@AAAS.org. And to stay up to date on our other events, as well as blog posts and more, follow us on Twitter, LinkedIn, and you can subscribe to our mailing list on our website. Once again, thank you all for joining us today.